What is a lunar day, and how does it differ from a day on Earth? On Earth, a day is about the time it takes for the Earth to turn once on its axis with respect to the Sun. A lunar day is about the time it takes the Moon to turn once on its axis with respect to the Sun. And that's about 29.5 Earth days, so it's about a month. Now, you may be confused about how the Moon rotates if we always see the same face from Earth. The answer lies in a process called synchronous rotation, which is caused by tidal forces between the Earth and the Moon. We always see the near side of the Moon because as the Moon orbits around the Earth, it is also continuously turning. In fact, it rotates at the same rate it orbits the Earth, on average. So, a lunar day takes about the same amount of time as one complete lunar orbit. 100 lunar days means 100 chances to observe a complete day-night cycle on the Moon, photographing the surface with different sun angles, measuring the rising and falling temperatures, and studying the way certain chemicals react to those daily changes. In the time before the Lunar Reconnaissance Orbiter, most lunar orbiting missions had a lifespan of 1 to 2 years. But now, LRO has shattered all records and been at the Moon for 100 lunar days. That's 8 years of data collection. This mission has truly ushered in a new era of lunar and planetary science. One of the biggest accomplishments is that LRO's high-resolution camera has been able to image almost the entire lunar surface, down to 1 meter of resolution. This has opened a treasure trove of new data about geological processes and areas that may be best suited for future exploration. 100 lunar days has also given us more time to study the Moon's far side in more detail than ever before. We now know, for example, that the Compton-Belkovich volcanic complex formed from a rare type of lava about 3.7 billion years ago. This helps paint a new picture of the Moon's history. The Moon has not only had a wide range of complex geologic processes, but its volcanism may have also changed over time. LRO has also been able to measure something you may not have heard about, the lunar tide, or how much the Moon's surface actually flexes and cracks due to the gravitational pull of the Earth. There's still a lot to learn about this ongoing process, making our Moon an important case study when thinking about other planets and moons. Over its lifetime of 4.5 billion years, the Moon has also been bombarded by all sorts of asteroids and comets. This has left millions of impact craters on the surface. For planetary scientists, however, there had been no way to identify newly formed craters. But when LRO arrived, all this changed. By comparing pictures taken earlier in the mission with more recent images, NASA scientists have discovered more than 60 new impact craters, like this one from 2013. And that's not all. LRO's instruments are able to study both new and old craters in ways we never have before. LOLA, for example, helps create topographic 3D maps, and Mini-RF has detected evidence of water ice inside deep craters at the lunar poles. All of this is important for space science as a whole. Craters are used to help determine the age of a surface, how hot or cold a planet is, and how thick a planet's atmosphere might be. Observing new impact craters also gives us better insight into what happens when a meteorite strikes a planetary surface. And this touches upon a key point. Our Moon is more than just a rock. It's the cornerstone for understanding our solar system and beyond. It has a dynamic history that we are still learning about, and features we are still discovering. By being at the Moon for 100 lunar days and counting, we continue to expand our knowledge of our nearest neighbor in space, and with that, the rest of the universe.